Hi, I'm Ben Solomon. In this video blog, we look at the main points brought up by the Bloomberg TV program, The Next Space Race. In this Excel spreadsheet, I've compiled the various costs of SpaceX and the NASA's Shuttle program costs, and these are the sources of information. The reason why I use SpaceX because their numbers were the easiest to get. I have made available this Excel spreadsheet in the text of the blog. Zooming into the various types of costs, we see that the anticipated NASA mission cost per the Bloomberg TV program, The Next Space Race. SpaceX full complement is seven astronauts, and the number of launches they expect is 4. And the mission cost per astronaut per launch is 20 million. Therefore, the total launch cost, assuming 7 astronauts, is 140 million, and the total cost per year for 4 launches is 560 million. Now, if you zoom into NASA's Space Shuttle program cost, there's a little bit of difficulty here because of inflation, estimating inflation and changes in the cost per shuttle. As you can see from this is a University of Colorado Boulder estimate of the total expenses of the shuttle program since 1971, and these are the cost in 2010 in billions of dollars, the purple, and the blue is the number of shuttle flights in that year. So you can see that the shuttle flights started sometime much later than the program started. We do this estimates with a pinch of salt because there are some adjustments we have to make to reconcile the numbers. The original development shuttle cost was $90 billion, and up to 2010 they had 131 flights. Converting this into 2011 dollars, when the shuttle program came to an end, it's 189 billion. And if you bring it up to 2012, the same year as SpaceX data, it's 194 billion. And this is CU Boulder's estimate. They estimated the total cost over 131 flights was about 1.5 billion, which matches this number if we use an average inflation rate of 2.5%. And we can see from the previous graph that shuttle costs was declining towards the later years. And therefore, if we use this number and convert it into 131 flights, we get a number of 197 billion, which matches these two numbers, which matches this number quite well. So this tells us that the estimated inflation for the NASA shuttle program was about 2.5%. And if we take the depreciation out, all programs will have a certain amount of depreciation. If we take 90 billion spread over 30 years at that constant rate, and we take it out of this number, we get an estimated operating cost launch in 2012 numbers as about $813 million per launch. Of course, this is a crude way of estimating the operating cost per launch, especially when you can take issue with 193 billion and 196 billion. But in the absence of not having any easy data, this would be an acceptable estimate of the shuttle launch operating cost. And if you compare that with SpaceX anticipated launch cost of 140 million, we see that SpaceX operating launch cost is about 17% of the NASA shuttle programs. Now let's look at SpaceX numbers again. Elon Musk, in his Popular Mechanics interview, said that the payload, non-reusable payload, cost is $1,000 per pound. given that Falcon 9's payload capacity is 29,000 pounds, that gives a payload of cost of $29 million. And he said the minimum reusable cost he expects is about $10, which gives a payload cost of $289,000. His anticipated grasshopper cost at $100 a pound. The grasshopper is how he does the vertical takeoff and landing. That gives $3 million total payload cost. Based on a 29,000 payload capacity, the SpaceX cost of $140 million gives an actual payload cost of, or maybe payload revenue of $4,800, almost $5,000 per pound. And if we convert this $100 grasshopper adjusted to this 4,800, we see that the grasshopper anticipated cost would be about $500 a pound. So the conclusion we derive is that $10 per pound is the theoretical minimum. It's probably not achievable, and so is the anticipated grasshopper cost of $100 per pound is also a theoretical minimum, and the actual realizable numbers are $5,000 a pound for non-reusable rockets and $500 a pound for reusable rockets. So that tells us that if an organization like Planetary Resources would be using SpaceX rockets, their ultimate cost per pound would be on the order of $500 and $5,000 per pound. But Planetary Resources said that the cost of launching 1 ton of water, that is 2,000 pounds, would cost $50 million, and therefore the estimated cost per pound is $25,000. And when we enter this $25,000 per pound back into Falcon 9 payload capacity of 29,000 pounds, we get a launch cost of $700 million, which is comparable to the shuttle launch cost of $800 million. So we know that this $25,000 per pound is an old cost number coming out of the shuttle era. Therefore, we can disregard the $50 million launch cost for 2,000 pounds of water. So if you look at SpaceX launch cost of between $5,000 and $500 per pound, we get Planetary Resources accurate telescope of 30 pounds costing between $145,000 and $15,000 per telescope, depending on what is used. This tells us two pieces of information. With a launch cost, payload cost of $145,000 compared to a SpaceX launch cost of $140 million, it tells us that Planetary Resources will piggyback off somebody else's launch to achieve that $145,000 cost. Secondly, it tells us that since their Kickstarter program required $1 million, the operating cost to develop and assemble and put the satellite together cost about $850,000. So where do we go from here? We can summarize a few important points. First, that for the next space race, the launch cost payload launch cost per pound will be on the order of $500 per pound to $5,000 per pound. Given that the shuttle program approximate cost was about $25,000 per pound, it is most likely that the initial launch price for the next space race will be $5,000 per pound. The second important point is that if we look at NASA's cost of development of the shuttle program at $90 billion versus SpaceX of $300 million, it tells us one very important factor, that NASA bore the brunt of the research and development at 90 billion, and SpaceX, by their own admission, have bought off-the-shelf equipment to develop their Falcon 9 rockets. Don't get me wrong, they did some research, but it was not on the scale of the NASA's 90 billion. For example, SpaceX, they did not rebuild or reinvent the rocket engine. They used the existing Merlin engine. And unfortunately, the third most important point is the downside. If you have used off-the-shelf rockets, rocket technology, software to build together a launch company that can launch at $20 million per astronaut or $140 million per launch compared to a previous 90 billion for NASA at 800 million per launch. That tells us that anybody and everybody can come on board to do the same thing. All you need is about 600 million in investment, maybe 700 million investment to get this up and running in a few years.